Hello everyone, I am Anamika Goyal from ABES Engineering College, Ghaziabad. In this lecture, I am going to discuss about multiplexing and demultiplexing in transport layer. In this lecture, basically, first we'll discuss about the definitions of multiplexing and demultiplexing. After that, we'll discuss about the addressing at transport layer. Then we'll discuss about port number classifications. After that, we'll discuss the process of multiplexing and demultiplexing with the help of block diagram. So now, first of all, what is multiplexing and demultiplexing? Multiplexing and demultiplexing are the most important functionality in the transport layer of OSI model. These functionality are essential for managing the data transmissions between multiple applications running on a single machine. If I am talking about the multiplexing process, so the multiplexing, it is the process where we combining the multiple data stream from different applications into a single data stream for the purpose of the transmission. Now, what is the goal of the multiplexing? Actually, the primary objective of the multiplexing that the number of applications which are running on a single machine can share all the network resources in an efficient manner. That is the primary objective of the multiplexing. Now, if I'm talking about the demultiplexing, so demultiplexing, it is the process which perform at the receiving end. At the receiving side, the data coming from a single data stream which convert into the various different data stream to deliver the intended receiver process. So this process is called demultiplexing. It is the process of separating incoming data from a single data streams into a multiple data stream. At the transport layer, we have two most important protocols, that is transmission control protocol and user datagram protocol, for the purpose of for doing multiplexing and demultiplexing functionality. If we use user datagram protocol for the functionality of multiplexing and demultiplexing, then this type of process is called connectionless multiplexing and demultiplexing, because UDP, it is a connectionless protocol. If we'll use transmission control protocol for the functionality of multiplexing and demultiplexing, in that case, this kind of process is called connection oriented multiplexing and demultiplexing, because TCP, it is a connection oriented protocol. To perform these functionality at the transport layer, we use a unique address for the purpose of the identifications of various application uniquely. We use 16-bit unique address, that is called source port number or destination port number. Now we'll discuss about addressing at transport layer. As we know, when we want to deliver something to some place, so in that case we require address. So similarly, in the case of transport layer, when we want to send some segment from the sending side machine to the receiving side machine, so in that case we also required a transport layer address. In case of transport layer, we use a socket address. Socket address is nothing but it is a combination of IP address or a port address. Here we use IP address for the IP as a IP address for the purpose to uniquely identify the host which are available in the network. So, IP address basically used to identify the unique host available in the network, and the port number which is used to identify one of the process on this particular host. Right? Now, port number. What is port number? At the transport layer, we use TCP and UDP protocol. So the range of port number is vary from 0 to 65535, because here we use 16-bit port number. So the maximum port number is 2 raised to the power 16, that is 65535. So as according to the IANA, Internet Assigned Number Authority, it divided the available port number range into a three category. So first category is well-known port number. These port numbers are ranging from 0 to 1023 are assigned and controlled by Internet Assigned Number Authority. These are called well-known ports. For example, if I want to access google.com or any other web pages, then in that case, we use a port number 80 because port number 80 is a well-known port number for accessing any web page in the internet. Second categories of port number is registered port number. The port ranging from 1024 to 49,151 are not assigned or controlled by IANA because they can only be registered with IANA to prevent duplication. These are called registered port number. Last categories of port number is dynamic port. The range of dynamic port number is vary from 49,152 to 65,535. These are neither controlled nor registered. They can be used by any process. These are the port number assigned by the operating system to all the existing process running on a machine in a network. I hope you understand port number. Now, we'll discuss the process of multiplexing and demultiplexing in detail. As I told you, to perform the multiplexing and demultiplexing at the transport layer, we require port number, which is a 16-bit unique integer to uniquely identify all the available process uniquely. We also require another address, that is IP address, which is used to uniquely identify the source machine or destination. This is a 32-bit address. So the combinations of IP address and port number is called socket address, right? So in case of multiplexing, when the data is sent from multiple applications to a single machine, that is called client machine, the transport layer adds its header to each segment, which include destination IP address, destination port number, sequence number, and many more information, so that we can identify the application data is which application the data is coming from. That is called multiplexing. Similarly, at the demultiplexing process, when the data arrive at the host, the transport layer look the incoming message and check out the destination port number. On the basis of the destination's port number, transport layer can identify which applications or process on the host should receive these data. So basically, these are the structures of to perform multiplexing and demultiplexing. To understand this concept clearly, let us take an example. Suppose this is a client side machine, machine A, and this is a receiving side machine, this is B. In that, to understand the concept of multiplexing and demultiplexing, suppose client machine A want to send some messages to the receiving side machine B using different kinds of applications. Suppose client A want to send one message to the receiver B using WhatsApp application, right? WhatsApp application, that is what? That is process 1. Client machine A also send one more message to the receiver B, but in that case using different application, that is Yahoo Messenger. So that is process P2. So here at the client side on a same machine, we have two different application, that is two process. One is P1 for WhatsApp application. Second one is P2 for Yahoo Messenger application. In that case, operating system will assign different port number for WhatsApp application process and for Yahoo Messenger application process. So in that case, what happened when client sent a message to the receiver B? In that case, client A use destination's IP address of machine sender B, receiver B, and the port number of WhatsApp application, right? Port number of WhatsApp application like 10 or 20, right? So here process P1 use port number 10 for WhatsApp application and destination IP address of B and send a message to the receiving side. Another application of sender side is Yahoo Messenger application. In that case, again, machine A, that is sender A, send a message using Yahoo Messenger with the IP address of destination machine, that is B, and the port number of application Yahoo Messenger, like it is 20. So the another port number is 20, and send these two message from sending side to receiving side machine. Now, in sending side, we use a device that is called multiplexer, which will receive multiple data stream messages and then convert into a single data stream. So it is what happened? It is just wrapped these two messages into a single message and send it to the receiver. At the receiver end, what happened at the receiving end? Transport layer look at the destination port number of these two process, that is process P1 destination port number is 10 to in receiving side we use another device that is called demultiplexer, which receive a single data stream and convert into a multiple data stream on the basis of their port number. So it can deliver process P1 to the port number 10, that is WhatsApp application, and also deliver process P2 for the port number 20, that is Yahoo Messenger application. So this is what this is called demultiplexing, right? So actually this is the overall working of multiplexing and demultiplexing at the transport layer, which is mandatory to require that we use IP address of the destination machine and the port number of a required application. So I hope you understand the working of multiplexing and demultiplexing. These are the reference slide using to design this lecture. Thank you for your patience.